Let's talk about how we can use OpenID Connect to access protected REST APIs. First, I want to describe the problem that we're trying to solve. Then I want to introduce two tools that can be used for obtaining access tokens on the client side. Finally, I want to introduce a tool used to implement the server side. So the problem we're trying to solve is that OpenID Connect is most often used in the browser-based flow. That means after a successful login flow, the token ends up at the web server, which can then access APIs and display the result to the user. Direct access, where the web browser is not involved, is not so well supported. The first approach, the simple approach to simply copy-paste tokens from a web page that display the token to the user, is not so feasible because these tokens typically have a lifetime of only 1 hour. Our goal is to support non-web scenarios with the least amount of user interactions that are possible. And we have two particular use cases that we address with the technologies described. The first one is the authenticated access of remote services, be it from the command line or from the desktop, and be it, for example, access to remote storages or even SSH. The second use case is to support long-running compute jobs where the jobs typically run longer than the lifetime of the tokens. Let's start with OIDC Agent. The goal of this tool is to provide access tokens to the user with minimal user interaction. The analogy to the SSH agent is intentional. So it runs on the local workstation of the user. It stores private keys, in our case the refresh token, on the local workstation of the user. It provides a few commands to interact with the agent. OIDC Gen generates an account configuration with a remote OIDC provider. OIDC Add loads that account configuration into memory, and OIDC Token uses that loaded configuration to obtain access tokens. Some words about security. OIDC Agent uses refresh tokens, which require a very high level of protection because they live very long, and once they are stolen, the attacker can impersonate the user for a very long amount of time. That's why OIDC Agent always encrypts refresh tokens when stored on disk, and even encrypts them in RAM with a dynamic password when loaded into RAM. Using OIDC Agent is quite simple, as we will show with these few examples. So once in the lifetime of a refresh token, so once about a year, you need to create a configuration with a command like this. We specify the scopes that we want to have. Max specifies all the scopes that the server advertises. We will use the eduteams proxy in this command. Then we're being redirected into the browser, where we have to authenticate. Due to single sign-on, I'm already logged in, and I can simply return to the process that started the command, and we have to enter our password. Once after reboot, we have to load the configuration into memory. This may be skipped because OIDC Token automatically loads the configuration whenever it is needed. And so we can now use one of these two commands to obtain access tokens. We can refer to the agent configuration with either the short name that was specified before, or we are specifying the OIDC provider that was used, as you can see here. So we can simply get an access token like this, and we can look at the access token with a simple shell script that we provide here. So you see all the information that is stored in this particular access token, which in my case is the list of scopes, the assurance, name, subject, entitlements, and so on. Even an SSH key is transmitted in this token. And with this, we can address use case 1, which is the authenticated access to remote web services. Here we access the remote endpoint of the eduteams proxy with curl. We access the protected resource user info endpoint by putting into the header the authorization bearer statement with our OIDC token that we have. And for visualization, we pipe this through the JQ command. And this looks like this. And here you see all the information that is stored about my token at the OP. It's again the assurance, my subject, my name, the entitlements, and so on. With this, we can consider use case number 1 solved. OIDC agent is supported on a variety of platforms. This is a couple of Linux distributions, but also macOS and Windows. Let's talk about my token. My token is documented in this URL. The goals are to provide access tokens for long-running jobs, to not have any interaction with the user after my token was created, and not to release any refresh tokens to the infrastructure. The challenge with my token is to balance the security versus the convenience, as we will see. And our approach is to introduce a new server, the My Token server. The My Token server obtains refresh token via the auth code flow. It introduces a new token type called My Token. And the refresh tokens stay on the server. They are encrypted with the My Tokens, and the My Tokens are passed to the client and not stored on the server. How does the balance between security and convenience look like? My tokens are JOT style tokens. They support capabilities. What can I do with my token? And it looks like this in web front end. You can set the capability that allows to obtain access tokens, to obtain information about the token, to list the My Tokens, to revoke the tokens, to create new My Tokens, and so on. My Tokens can also contain restrictions, which talk about what are the limits in which I can use my token. This looks like this. I can put multiple restriction clauses. For example, my token might not be used before or after a certain time frame. Can limit the scopes to which the generated access tokens have access. You can limit it to audiences. You can limit it on a geo-IP base. You can also limit it on IP addresses. You can limit the amount of usages for generating access tokens or other usages, and so on. My tokens also support inheritance, so you can use a My Token to create another, more limited My Token. Of course, you cannot escalate the privileges. To see it live and in color, you can visit My Token DataKit edu or the documentation page. This brings us to the demo. There are two ways to obtain My Tokens. One is the command line and the other one is directly from the web server. This command line flow specifies that we want to use OpenID Connect to authenticate, which will straight lead us to the web front end. And we already specified that we want to get a My Token that works with the issuer of the proxy edit teams. So we simply enter this command. This gives us a URL that we can visit with a device of our choice. And when we get there, the My Token is already created and we have to approve the creation of the token. But we can also edit what this My Token will be able to do. So we could, for example, add the capability of creating other My Tokens, which is not selected by default. We can change the lifetime. So this My Token should actually expire today at 8 o'clock. And it should also be available for usage next week for a whole day. This is the easy editor, the graphical mode. This is always translated into a JSON that you can view in the JSON editor. Once we continue, due to single sign-on, we are already logged in. Edit team simply asks us for the approval of the release of data. And then we can go back to our client at which we started. This is the My Token that we just obtained. We will store it in an environment variable for convenience so that we can use the My Token later on. So what can we do with the My Token? We can first take a look at the My Token itself. This shows us the JOT structure of the token. We have a header, we have a body, we have a new token type, My Token, we have an issuer, which is the My Token server, we have a subject, we have the capabilities that we selected before. Remember the create My Token that we specified, and we have a lifetime of the whole my token, but we have also restrictions that restrict the lifetime of the token. So these are the two lifetimes that are selected, basically of today at 8 o'clock and next week for a whole day. We can also get another my token, which is restricted a bit further with this command. See, I've restricted the lifetime of the token, which is now reflected over here. Also, the new my token cannot create any sub my tokens, as you can see in the capabilities, because the create my token capability is now missing. We can also get an access token from a my token with the AT command. And as you can see, I can get an access token that looks just like the one I've obtained before from OIDC agent, because it refers to the same identity at EduTeams. Summarizing, with my token, it can be adjusted to the situation in which I want to use it. They can be as safe as possible and as unsafe as necessary. Of course, they can be revoked as well. And they can be used just as any other OpenID Connect JOT token, because my token is very similar to an OpenID Connect provider. The my token server will soon be hosted within a safe credential store requirement according to the EU Grid PMR credential store requirements, and clients are supported on Linux, macOS and Windows as well. Let's take a look at the server side. There I want to present the tool Flat, which is auto-documented at Read the Docs. The goals of Flat are to provide a Python interface that is simple and flexible to use and allows you to just add AI to your Python REST API. Flat supports a couple of web frameworks. This is Flask, Fast API and IO HTTP. The usage is quite straightforward. You first define requirements on the incoming user and then use a Python decorator to enable the access control. So we will see how this works in practice in a bit. Flat supports natively ARC entitlements, but also any kind of group membership requirements. It can be used to support other profiles as well. So the WLTG or side tokens kind of attribute management and group expressions are supported. Flat requires Python newer than 3.6. Let's take a look at examples. The simplest example is to require an authenticated user. Here we see example code for the Fast API. So for the endpoint authenticated, we simply require the Flat decorator is authenticated. And then this function may only be called by authenticated users. I've prepared a short example code that we can take a look at. Here we import the necessary dependencies. We set the list of trusted OPs that we trust. The one we're using is EduTeams. It is over here. And over here we have the example code. So the endpoint authenticated simply needs any kind of authentication. And here I use the HTTP client to access the local host. I use the OIDC token EduTeams. Just start the Python code and I can access it. That was very login. I can use any other identity that I have in my OIDC agent, so EGI would work just as well. The next example is slightly more complex. Here we require the user to carry two entitlements, namely the EduTeams group Lago AI and the EduTeams group EduTeams. We look for the entitlement in the EduPerson entitlement claim, and we want 2 of 2 entitlements to match. For this, we define the getVO requirement function and pass it as a parameter to the Flat requires decorator, and then this authorized VO endpoint is protected. This is the code of the example, and here we can run it. And you see it works with the required entitlements. If I use my other identity, I'm still authenticated, but it doesn't work because I'm not authorized. Summarizing flat is we have a simple support for enforcing AI in Python REST interfaces. Summarizing this talk, we can say that using OpenID Connect and REST APIs is straightforward on both client and server. Of course, I need to mention that the presented tools are only a subset of available tools for OpenID Connect implementations. All these tools have in common that they are developed in our group at the Karlsruhe Institute of Technology. And for questions on them, you can contact me at hart@kit.eden. The scripts and slides used in this presentation are linked in the comments on the YouTube channel.